Hello students, good morning. Myself Mr Deshmane from MPSC College, Panvel. Today I am going to teach you the concept from 12th Science Physics, topic number 17, which is semiconductor devices. In this semiconductor devices, I am going to teach you today half-wave rectifier. So today we will see the content from chapter number 16, semiconductor devices, from which we are going to study PN junction diode as a rectifier. There are two types of rectifier: half wave rectifier and full wave rectifier. So now we'll start with half wave rectifier. Before going to start with half wave rectifier, first we will see the meaning of rectifier. What actually the rectifier means, that we will have to see first, and then we will go further. Rectifier is nothing but the conversion of AC voltage into DC voltage. This process where we convert AC voltage to DC voltage is known as rectification, and the circuit which converts this will be known as rectifier circuit. So there are two definitions given over here, that is rectification and rectifier. Rectification means the conversion of AC voltage into DC voltage. As we know that AC voltage is having positive cycle and negative cycle, it means that the direction of the current changes. This current that we are going to convert into DC means the direction will remain in same way, either in the positive cycle or in the negative cycle. And the circuit which converts this will be referred here as rectifier. So these are the two definitions from this half-wave rectifier. What is meant by rectification and rectifier? Rectification means conversion of AC voltage into DC voltage, whereas rectifier means the circuit which converts AC voltage to DC voltage is known as rectifier. So for this rectifier, there are two types present. Types of rectifiers. One is half wave rectifier and the second one is full wave rectifier. In this lecture, we will study more about half wave rectifier, and in the next lecture we will go for full wave rectifier. So now we will start with half wave rectifier. Before going to start with this concept, the experimental setup which we are going to do the experiments in laboratories is shown over here. Here we are having the circuit which we are going to call it as rectifier, for which we are going to apply the AC source having certain frequency, which is converted into a DC source. Here AC input was present, input cycle was shown, and for that the output will be having only positive cycle, so it was converted into a DC source. So this one was the only picture shown for our understanding. While doing the experiment, this method that we are going to use. Now next, PN junction diode, which is used as a half wave rectifier. So the circuit diagram for studying half wave rectifier is shown over here. It is having a transformer. For the primary of the transformer, we are going to apply AC source, As it was AC source, so we are going to show here by using the AC source symbol. And it is coupled for the secondary, the same source whatever present as the primary will be used as secondary, but the voltage will reduced because the number of turns present over here will be less as compared to primary. As we have seen in case of transformers, there are two types of transformers present: step up transformer and step down transformers. Here we are going to use step down transformer so that the voltage will be somewhat reduced, and we are going to use the diode which we are going to call it as PA junction diode D. Through the load we are going to connect back to the given transformer. For this load we are going to measure the output across load, and for that output we are going to obtain only DC. Now we will see the working of this diagram. When positive cycle from the AC source will appear over here at secondary, so here the positive cycle will be appearing. At that time the diode D will be in the forward bias mode. As it was in the forward bias mode, so current easily flows through the diode. For the given condition, when positive cycle of the current comes, so the diode will be in the forward bias mode. It conducts easily and the current flows through the given load resistance and it will come. So the output that we are going to obtain for the positive half cycle will be present. Suppose that now the negative cycle of the current was appearing over here at A. So when there will be a negative cycle present at A and it starts moving, now the diode blocks the current because the diode will be now in the form of reverse bias mode. As it was present in the reverse bias mode, the current will not flow through the diode. As the current is not moving through the diode, so the output will not be present for the negative cycle. So for both cycles, when we consider positive and negative, we get the output as positive cycle as it is because the diode will be forward bias mode, and for negative it will be not conducting, so it will remain as it is. For again next cycle when appears, again it will be conducting over here for positive, and for negative there will be no current present. So only we are going to obtain the output for the positive cycle of the AC source, as only half of the wave will be rectified over here. So for that purpose the circuit represented over here will be termed here as half wave rectifier. It means only half of the wave of the AC source will be rectified as the output. Negative cycle will be blocked. Suppose we want to rectify the negative cycle, then instead of using the diode over here as shown, we will reverse its polarities. Then the diode will conduct for negative cycle. So you may rectify either positive cycle or negative cycle depending upon the situation, and accordingly we are going to use the diode either in the forward bias mode or in the reverse bias mode. So the explanation was given over here on this slide. AC voltage across the secondary coil AB changes its polarity after every half cycle. So after every half cycle, as the polarity goes on changing, during the positive half cycle, the voltage at the point A means the voltage across the diode will be at higher potential with respect to the point B. Therefore, the diode is in the forward bias mode and it conducts the current. This current easily flows through the given load resistance from diode to point B. When there will be a negative cycle appears, negative half cycle begins, then the potential at A is lower as compared to the point B. Now the diode is in this case as reverse bias, so it blocks the current which is moving, so hence it does not conduct the current through load resistance in any direction. As it is blocking over here, so we are going to obtain only the positive cycle. Here some animation was shown for the input signal, for which we are going to obtain the output as positive cycle only, not for the negative. See here, we are having AC source. As the source is AC, it is having positive and negative cycle. For positive cycle, here the charge will be moving through the given diode and load, and for negative it comes over here and then it blocks. So the animation is shown over here. Observe it carefully so that one can understand how the current moves or how the current blocks through a diode. See here, when negative cycle start, current starts moving, but the diode blocks that current, so it will not flow through load. Therefore, it will appear as stationary. But for positive cycle, the current will move through the given load resistance. Observe it properly, then you understand how the current conducts in case of a diode. See here, the current is now conducting. Now the current is blocking over here. So the output waveforms for this given half wave rectifier. As the diode conducts the positive cycle only, it blocks during the negative cycle. The current will move through the load resistance in only one direction, that is AC current is converted into unidirectional DC current and the circuit acts as a half wave rectifier. The input and output waveforms are shown in the next slide. So see here the input and output waveforms which are present for half wave rectifier, as it was the diagram which we are going to do the experiments in our laboratory. So here the experimental setup was shown, for which we are going to represent the input and output waveforms. As here the input waveform is the AC source, so it is having positive cycle along with negative cycle. So all positive, negative cycles were present and they are going to change with respect to time. So we call it as input AC source. For the same, the output will be present only for the positive cycle as the current conducts during the positive cycle, and for negative it blocks over there, so it will not appear. Again for positive it conducts the current, again for negative it blocks, so only we are going to obtain half of the cycle. Therefore we say that it is an half wave rectifier. Is this clear? Okay. In the next lecture we will continue for full wave rectifier. So I am going to stop over here for this presentation, and during the next lecture we will continue with the second type of rectifier, that is full wave rectifier.